chart, and the flow chart says it's going to help you make a decision which one should you use. We learned two things so far. We learned the z-score, we learned the t-score. Now, the z-score we used when we knew the population standard deviation. A t-score we used when we did not know the population standard deviation. So let me see if I can just shrink this in a little bit more. I want that note down there. Okay, better. All right, so let's walk through this flow chart to see how this works. So to determine which one you should use, a Z or a T, you want to know major thing. Do I know my population standard deviation? And I put this on your note page. If you do know your population standard deviation, yes, you have to do two things now. Either your population is normally distributed or n is greater than or equal to 30. Remember, we've been checking those. If they don't say that, we stop right there. We cannot do it. If we know that one of these conditions is true, then you can use your E, and then it's set up the same way. If you do not know your population standard deviation, that means you're taking it from your sample. You still have to be told that it's greater than or equal to 30 or it's normally distributed. Then you can use your T. And your T uses the degrees of freedom, and then the rest of it works the same. So keep this flow chart handy. Now notice it says, if the flow chart is less than 30, if n is less than 30, your sample size is less than 30, or it does not say it's normally distributed, you can't do any of these because it will not approximate a normal curve. And even your T is a series of curves until it gets close to your normal curve. So this is one of your criteria to use. So let's take a look at this example in your book. Read with me on this, because if I move this flow chart, then we won't be able to see it. You randomly select 25 new houses. So n is 25. Let's write our criteria. The sample construction cost is 181,000. And the population standard deviation is 28,000. It says, assume the construction costs are normally distributed. They want to know, would you use a z-score, would you use a t-score, or would you use neither? So we walk through. Here's our information. We walk through. Do we know the population standard deviation?
Yeah.
Yes. So we're in this test. Is the population normally distributed, or is n greater than or equal to 30? Well, if n is not greater than or equal to 30, but did they tell us it was normally distributed?
Yes.
Then yes. Then we use your z-score formula. This is from 6.1. Here's the big difference, okay? So we check to see if the population standard deviation was there. If all was good with my curve, then I use the z. That simple. Look, you try it yourself, number 4. You randomly select 18 male adults, athletes, and you measure their resting heart rate of each. You have a sample mean heart rate of 64 beats per minute from your sample, with a sample standard deviation of 2.5 beats per minute. Assuming that they are normally distributed, the heart rates are normally distributed, which one can you use? So let's walk through. I come down, do I know my population standard deviation?
No.
No. I'm in the no section. Is my population greater than or equal to 30? No. But is it normally distributed?
Yeah.
Yes. So therefore, I can use my T distribution, which is the one from 6.2. We use the t-score, we use everything else. Now, I'm going to change this. We agree we can do that one. If they told us this much information, but did not tell us that this was normally distributed, we would come down here and we would say, well, is it greater than or equal to 30? No. Is it normally distributed? They never told us that. No. Then, therefore, I can't do anything. I say, nope, can't do it, can't use it.
So it says it's not normally distributed?
Well, they won't say not, they just won't tell you that it is.
Oh, okay.
So, like, I took it away this time. But I took it out of the problem. So we check the end, it's not greater than or equal to 30. But then if they didn't tell us it was normally distributed, I can't assume that it is. So therefore, I'm going to have to say, can't use either one. Okay? And that's the big difference between using a z-score, that we did last unit, 6.1, and using a t-score, this one. Okay? Here's your homework. The first part is just asking you to look this up on your table. You're going to look up the first pieces on your table to find your TC. I did the sketch so that you would remember it's halfway in the middle in case you do the inverse T. If you do inverse T, then you have to do the 1 minus 0.90 divided by 2 and degrees of freedom. If you do inverse T. I think it's far easier to look it up on your table. So write those problems down. You have probably 20-something minutes in here. I don't think it will take you longer than that. The first 3 you can just look up on your table.